Hello, welcome to our Design for Manufacturing interim presentation. My name is Connor, and along with Stephen, John, Tristan, Pedro, and Jonathan, we'll be presenting our research on the Philips hand blender. Hand blenders are used in a lot of food industry related roles. The total market share for these blenders is approximately 73.5 million blenders per year. And with an assumption of 1% market share for our product specifically, we estimate that there will be a production of 735,000 units per year. Here you can see a few different views of our assembly. And on the next slide, you can see an exploded CAD view, which details all 16 parts of our assembly. For our primary and secondary customers, we assume that our primary customers will be restaurants and home cooks. And some of our secondary customers will be laboratories as they mean to use hand blenders to mix chemicals.
Thanks, Connor. Now, speaking about the fast diagram, we can see as our main function is blending chickens, and the two functions at the top are those functions that we need to blend those ingredients. The other functions that are at the same level as these ones are less important, but are also important for our manufacturing and our product to be successful. Then if we go to the assembly sequences, we can see the first one that starts with the chassis, number 5, and then we united the bottom 16, 6, 7, and 8. Once we've done that, we unite motors and the different covers, and then we finish with the parts on the downside of the blender, and the last part, the stand. If we go to assembly sequence 1, 2, we start with the lower cover, and the thing is, the chassis is already united with the bottom system, and the different subsystems were the same as assembly sequence 1, but in different orders. Now Tristan will speak about comparing these matrices.
Following with the two assemblies that Pedro just discussed about, we developed an assembly sequence comparison to see which one of them is better. And we came out to the conclusion that assembly one is better as it is easier to transfer and handle parts and to locate those parts on the different sub-assemblies. For the FTMM, we developed a table that relates the different functions established in the fast diagram to all the components of the hand blender, and we can see how every function is satisfied by at least one of the parts. For example, to reinforce protection and reduce weight, we can see that the logo cap and all the covers of the hand blender are the ones in charge of fulfilling this function. Now I'll hand over the presentation to John, who will talk about the bomb and the quad chart.
Thanks, Tristan. Here's our bomb. About half of our parts are made with ABS, and injection molding will be the process used. The other half will use two different forms of steel, music ware, and stainless, with various manufacturing processes, including sheet forming, turning, and die casting. The assembly process for this product is more conducive to manual assembly and are based on the first assembly process. The cost assumes a $15 per hour wage for the workers manufacturing the product, and the total cost arrives at $17.84. This is in line with a typical product in this segment, which retails for about $40 to $50. This is our quad chart classification. The highlights here are the open-ended spring, stand, and logo cap. The logo cap could be integrated into the top cover as it is primarily an accent piece. For branding purposes, the stand is optional as it is a quality of life feature and is not essential to the product. And the open-ended spring could be made a closed-ended spring to decrease assembly times.
Thanks, John. Now I'll take us into the product family design section. First off, we have our functional differentiation tables. On the left here, we have our groups from the fast diagram that are different among customer groups, such as achieve textures and develop rotation. On the right here, we have our modules that differ from our two customer groups. The blade cover, blade shaft, and blade will be different among the customer groups.
Thanks, Stephen. Here you can see the CAD models of the modules for the primary and secondary customers. The primary tool is what comes already installed on the part, and there are two additional attachments that it can be replaced with, one of which is a potato masher and another of which is a whisk. The interface by which these parts are attached and removed has one end for the tool and another that connects to the motor. It is a simple connection between the two parts in terms of non-electronic parts. Now I'll hand it back off to Stephen to finish out the presentation.
Thanks, Jonathan. Now I'll take us into the product family assembly diagram. In our analysis, we discovered that this product is great for delayed differentiation. As seen in the chart, we go through 11 parts in assembly before it branches into two different items. This is great for reducing time, and cost during assembly. Thank you.